Welcome back. So today we're going to be looking at some more advanced uses of if and if else statements. So we'll go ahead and jump right on in. What I've got up here is just a simple example where I'm asking the user to enter a number between 1 and 10. But what I'd like to do is to check to make sure that their number is in fact between 1 and 10 and give them some sort of error message in the case that it's not. So one approach to this would be to first look at the different error cases. So if the number is supposed to be between 1 and 10, then if it's less than 1 or if it's greater than 10, those are both out of bounds. So I could start off using the ideas that we talked about last time and say, okay, well, one problem is if the number is less than 1, then in that case we'll just go ahead and tell them that that's too low. On the other hand, if the number is greater than 10, then that number is too high. And we can just check our work real quick here. So if I put a number between, I put, say, 4 in there, then nothing prints out because we didn't hit either error condition. Let me fix that. If I put in a 0, it says that's too low. I put in a 12, it says that's too high. Okay, so good so far. Of course, we'd also like to confirm if it was in the right range. And the first thing that we might try is we could say, okay, well, it's not one of these two cases, so we talked about using else to say, okay, well, if it's not this, then instead do this other thing. So I would say, okay, that is a valid choice. All right, so let's again test this out. Oops, what did I forget? Oh, I put the period outside. Okay, so I say 5 and it says that's a valid choice, and I think, okay, great, life is good. It's always worth checking when you make changes to code, not only inputs that would be affected by your most recent change that you know of, but to check other inputs just to see if anything else is altered. So I could say, okay, well, let's try 0. It says, for 0, it says that's too low, that's a valid choice. And if I put in 12, then it says that's too high. But so we've got this weird thing going on with 0 where it says both that's too low and that is a valid choice. And that has to do with how else works. Else only looks at is always tied to the specific if statement directly above it. So what we really have is we really have two statements here. This one here and this one down here. So when I put in a number like 0, it first says, okay, is 0 less than 1? In that case, that's true, so it goes in and does this. Then we get down to here and we say, is 0 greater than 10? Well, that's false, which means we don't do this, but we have an else attached to that if, so we say, well, since this was false, that means we go do the else section. And so therefore we say that 0, for 0 both that it's too low and also that it's a valid choice. Now, we can do situations like this where we've got 3 possible outcomes and we want to do one of 3. And the way that we do that is using what's called an else if construct. So the idea here is that by typing else if here, we have an if statement, and then now, so if this is true, we do this, and then if it's false, then we go into this if statement. If it's true, we do that. And if this if is false, then this else is tied to this if. So we have kind of this if statement with an else that leads into another if statement, which then leads into an else. So now, since all of this is part of this else, if we trigger this condition, we don't do any of the other options. Likewise, if we don't trigger this, we go down to this one and check this condition, and if that's true, we do this and skip over the rest. And if that's false, then we go down and do this one. And you can chain multiple options together. Like you can keep doing else if you have multiple other conditions. So you can view if else as a way of if else by this standalone will let you choose between 2 options. But then from there, you can chain more ifs and elses to select between 3 or 4 or 5 options, etc. So with this if-else setup, then now if I say 0, then it only says that's too low because it hits this and then the else skips over the rest. And then same thing if I hit 4, that's still a valid choice. And 12, it just says that's too high. All right, so this is one way of approaching this problem. I also want to look into, well, what if we want it to just say that's a valid choice or it's not? We want that to be the first option. So what I want to do is I want to build a condition that just tells me is the number between 1 and 10. Now, the first thing that someone might be inclined to write is something along the lines of this. You know, if we were dealing with math, this is how we'd write that condition, that number is greater than or equal to 1 and less than or equal to 10. And we'd say that is a valid choice. The problem is, unfortunately, in C++, so if I go to compile this will actually compile. And that's a little bit unfortunate for us because it's not going to do the right thing. The problem is that when we look at this statement, we see, okay, numbers between 1 and 10. When the computer looks at it, it sees 2 operators and it evaluates them one at a time. So it looks here, and when it goes to evaluate this expression, it says first, 1 is less than or equal to num. Say we input the value 5. So you actually see down here, warnings, comparisons like this do not have their mathematical meaning, which is exactly what this. So 1 is less than or equal to num. Say num was 5, it would say, okay, is 1 less than or equal to 5? That's true. Okay, that's good to go. But now when it gets to this statement, it'll look at what's on both sides, and it says on this side is 10 and on this side is true, and it's going to ask ourselves, is true less than or equal to 10? So that's not really what we want here. It's very much like if we had something along the lines of 3 plus 4 times 7, you know, or let me reverse these for order of operations. 3 times 4 plus 7. Then we would evaluate this as 3 times 4, which is 12. Then when we got to the plus, we wouldn't do 4 plus 7, we'd do 12 plus 7, because that was the result from the previous operation. Same thing happens here. Instead, we need to break this up into 2 pieces. And so to do this, we need there's a couple more comparison operations we need to make, or relational operations. There's the double ampersand, which is and there's this double vertical bar, which is or. And these 2 operations allow you to combine multiple Boolean statements together. In this case, for this condition, I want that num is greater than or equal to 1, and num is less than or equal to 10. So and combines 2 statements by saying that the whole thing is true only if both parts are true. So this matches how we use it in the English language. So for example, if I say, my name is Paul and I'm teaching CS161, then that's a true statement because both pieces are true. On the other hand, if I said, my name is Paul and I'm the starting quarterback for the 49ers, that statement is false because even though my name is Paul, you do not want me as your starting quarterback, trust me. So that's what this and statement here means. Or, what or means is that or means that at least one of these 2 statements is true. So getting back to that example, like if I said, my name is Paul, or I'm the teacher of this course, in that case, that's true. It turns out that both sides of that are true, but all or requires is at least one of them. At the same time, if I said, my name is Paul, or I'm the starting quarterback for the 49ers, that's also true, because I'm not the starting quarterback, but I am, my name is Paul. So one of those statements is true, so the overall thing is true. On the other hand, if I said, my name is Joe, or I'm the starting quarterback for the 49ers, that's false because neither of those statements is true. So in this case, we want both those conditions to be true, and so we put an and here. And if I go ahead and run this, then now I could put in, say, a 5, and that will work. I can then, to say that something's not valid, I can just use an else off of that. You know, that is out of bounds. So if it's not in between 1 and 10, then that means that it's not within my valid range. A couple of other quick pitfalls that people can run into, some things that we'll often try is, it's tempting to write things like this how we would say them. So for example, that num is greater than or equal to 1 and less than or equal to 10. That's oftentimes how we would say something like this, but this doesn't compile because each statement on the side of the and has to be a standalone valid expression. So num greater than or equal to 1 is valid, that stands on its own. But less than or equal to 10 is not a complete expression of itself. What less than or equal to 10 is what the compiler asks. So even though from an English perspective this is redundant, you really do need that num on both sides because they both have to be standalone values. Another thing that people will often want to do is something like num is equal to 1 or 3. And this is a little tricky because this will actually compile for a variety of reasons. C++, if you have a standalone number, C++ interprets 0 to mean false and any other number to mean true. So this standalone 3 here will actually compile. It's just that 3 will be interpreted as true. Not what we want here. Because it just looks at 3 and num equals 1. If we wanted to check if num is equal to 1 or it's equal to 3, we would have to have those full statements on both sides. So again, that's a brief introduction to using and or, some more complicated constructions with if and else statements.